Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the nature of roots of a quadratic equation. This is part 10. And I encourage you to check out all the other parts prior to this part, all on Numbers Simplified. And remember to subscribe so that you don't miss out on any of our future uploads on the quadratics list series or on any other topic that might be of interest to you. Let's look into today's business, the discriminant of a quadratic. If we have ax squared plus bx plus c, where a, b, and c are elements of real numbers and a is not equal to 0, then we say the discriminant is given by capital letter D is equals to b squared minus 4ac. Then there are three possible outcomes of the discriminant. 1. It may be greater than 0. 2. Equal to 0. 3. Less than 0, and all these cases have implications. Let's look at case 1 now, where the d is greater than 0, the discriminant is greater than 0. This implies that the quadratic has two distinct real roots or two intersection points. Now we have the first graph. If a is greater than 0, recall, we would have a minimum vertex, and if a is less than 0, we would have a maximum vertex. So the key point for case 1 is that we would have two distinct real roots or two distinct real solutions. Let's look at example 1. Find the discriminant, hence decide if the equation has two distinct roots, two repeated roots, or no solutions. Now we have x squared plus 9x plus 2 is equals to 0. The solution. We see that our a is 1, our b is 9, and c 2. So the discriminant is given by 9 squared minus 4 times 1 times 2, which is 73. 73 is greater than 0, implying that we have two distinct solutions. Now let's check this one out. Using the quadratic formula, we substitute for the a, b, and c, and recall the discriminant is that part that is inside the square root, which was 17 from our previous calculations. So we substitute for the other values, and solving, we are going to get two values, and separating the positive from the negative, we get these two solutions over here. It's evident that we are going to get two distinct answers. So our answer is correct, which are two distinct real solutions. Now let's look at case number 2. The discriminant being equal to 0, this implies that the quadratic has got one repeated real root, or it's a tangent. So if a is greater than 0, it will just touch, the vertex will just touch the line at one point, and the vertex is a minimum point if a is greater than 0, and if a is less than 0, then the vertex is a maximum point which touches the line at one point as well. Let's look at example 2. Find the discriminant, hence decide if the equation has got two distinct real roots or two repeated roots or no solutions. For 4x squared minus 4x plus 1 is equals to 0. Solution. So we see that a is 4, b is minus 4, c is equal to 1. The discriminant will be minus 4 squared minus 4 times 1, giving us a 0. This implies that we have one repeated real root. Let's check this fact. So using the factorization method, we are going to have 4x squared minus 4x plus 1 is equals to 0. And with that, we are going to have 4x squared minus 2x plus 1 is equals to 0. And factorizing the first two and the last two terms, we are going to get that. And eventually, we get 2x minus 1 times 2x minus 1 is equals to 0. We set the factors to 0 after separating them so that we get x is equals to half twice. So we've got the same solution repeated. Great. Then implying that that is satisfied. Let's get to case number 3, where we have the discriminant being less than 0. This implies that the quadratic has no real roots, no points of intersection or whatsoever. So if a is greater than 0, yes, we would have a minimum vertex which does not touch with the line. And if a is less than 0, we'll still have a maximum vertex which does not get into contact with a line. So no points of intersection or no real roots, no solutions. So now let's look at example 3. Find the discriminant, hence decide if the equation has 2 distinct roots, 2 repeated roots, or no solutions for 2x squared minus 7x plus 8 is equals to 0. The solution a is 2, b is minus 7, c is equals to 8, and the discriminant is given by minus 7 squared minus 4 times 2 times 8, giving us a minus 15, which is less than 0. This implies that we don't have real roots. Let's check this. Checking this using the quadratic formula. Substituting for the discriminant, which is minus 15, which we computed before, the one that goes in the square root sign, and substituting for the other values, we are going to note that the square root of minus 15 does not give real solutions at all. Therefore, we don't have any solutions for that particular problem. Let's look at example 4. Equation kx squared plus px plus 5 is equals to 0 has repeated real roots. Find k in terms of p. So the solution over here, a is k, b is p, c is 5. The discriminant is given by p squared minus 4 times k times 5, and this should be equal to 0 because we are informed that the equation has repeated real roots. Now with that expanding, we are going to get p squared minus 20k is equals to 0, implying that k is equals to p squared over 20. Congratulations if you have made it thus far into the video, and I'll leave you with the following task. Prove that the roots of the equation 2kx squared plus 5x minus k is equals to 0 are real and distinct for all real values of k. Remember, your experience in our sessions, your preferred numerical future topics, your questions, concerns, and suggestions are always welcome here. Make sure you type them in the comments section below. Thanks for watching Numbers Simplified. God loves you.